So after you pick your samples and add it onto the ones that you have already collected. And now we are going to demonstrate briefly how a zigzag is done within part of your field. So like I said, you have to divide your field where there is a non-uniformity. You have to divide your field into areas. For example, we are on the upslope of our field, and we are collecting samples from the upslope separately. In one homogeneous part of the field, you can collect around 10 to 20 samples uh, within that particular part of the field. And now I'm going to use my colleague, my boy here, to demonstrate how a zigzag pattern. So is demonstrating how a zigzag pattern across the field is done. And whenever it stops, there's a point where we pick our samples from. Yes, so where he has stopped is where we had picked one sample from, and he's going to do a complete Z shape within the field. Like we said, for zigzag, you make a continuous Z shape along the field. So as you can see, he's continuing, and this is one of the workers on the farm that I had picked, and you can see in one day he can demonstrate how a zigzag movement and where you can pick your samples. Is able to demonstrate it clearly, meaning anyone can comfortably use this method of soil sampling. So where he has stopped, that is where you pick another sample from, and now is moving to the other end of the Z shape again. Again, where he has stopped is where you pick another sample from. So along the patterns of that Z line in the middle, you can also pick your subsamples from the points along the Z shape, so that at the end of the day, you have picked around 10 to 20 samples, and it's a representative of that homogeneous part of the field where you are collecting your samples from. So we are now going into the next steps of preparing our samples for laboratory analysis. So out of the samples that we have collected, we are going to empty it into this small sack. You can see this is a combination of the samples that we have picked, and from each sub-sample, from each spot, we removed around 250 grams of soil from within each pit that we dug. But now we want to come up with a final of around a quarter to 1 kilo or even less that we are going to take into the lab. Now what we are going to do here is to remove all the roots that we have collected within this soil, plus the stones and other residues that may be present within this soil. And we also break these large pieces uh, and make it as smooth as possible. So this is all part of the preparation process for taking our soil to the lab. And we have remained with fine particles. You need to make it as fine as possible by removing all the roots and the large pieces of soil or particles that are within. So after doing that, uh, because I had said earlier on that we always want to try to as much as possible to avoid bias, and what we are going to do is divide our soil into 4 parts with your hand, into 4 compartments or 4 quadrats, and we are going to pick, as you can see, there are 4 parts. So we are going to pick this and this part, the parts that are opposite each other, because we want to minimize bias as much as possible so that we get a good uh, interpretation or an unbiased interpretation when we are making a recommendation. So this one you can put it elsewhere, or you can even pour it. You do this repeatedly until you come up with a final samples that you want to take to the lab. So you again divide this other part into 4 parts. And we are going to pick these 2 portions and put it back in our cavera. So the rest of this we are going to pour. Now I want you to observe the final bit that we are left with, and you can see this is about 400 grams, and this is what we are going to air dry. If it's so wet, you can air dry it briefly. Don't put it under the sun. You can air dry it under a shade, and you put it into your cavera or polythene, whatever bag that you can place it in for analysis in the lab. So this sample is a representation of the 5 acres that we are of the 5 hectares that we have in our land here. And in the lab, we are going to pick as much as I mean as small as this size, or even a spoonful. And that is why you need to be or try to collect a representative sample and be as less biased as you can, because you are using something small to interpret almost megatons of what you had in the field. So with the final that we had left, you just put it into a cavera, and you pack it or tie it properly. You can label it and place it into the envelope that we are going to take to the lab. And the all this information should be written on the label to guide the laboratory technician on where you have collected, the name of the farmer. All this should be placed on this envelope, as you can see, so that your sample is going to be returned to you. So you can take your sample to the nearest lab, and feedback will always be brought back to you. So as you can see, we have come to the end of our sample, and it's been a very hectic process because we had to collect samples from around 5 hectares of land. And now I am going to move back to our laboratory with this small sample. Dear viewers, thank you for watching. Don't forget to subscribe, like, and share.